This is video number 2 of the beginner series. Now in this one we're going to be starting some work on some logic, and that is going to really kind of put into place what we used our variables for in the previous video. So we're going to be covering some things such as the if, else, and the switch statement, as well as ElseIf. So these are going to be very basic, and we're primarily going to be using integers and booleans. Now I guess we can really just begin. So you can kind of think as this kind of logic as paths. So which path are we going to take? If we come over here and look at some Unreal Engine code, here I have a check. So if current magazine ammo, which is essentially just going to be checking if that is greater than 0, and B can fire, then we will take this path and run everything that is inside of here. And that was probably not a good example because there's no else to that. So better yet, let's do this guy right here. So here we do a check and see if we are aiming. If we're aiming, we do this. We fire from the aim down sights animation. If we are not aiming, because we're running the else, so literally anything other than the if statement. So if this if statement is false in any way, it doesn't matter if one check is true and the other one's false. If it's false, well, sorry, there's more to it than that, but if this if statement fails at all, the else will be what runs. So in this case, because we are not aiming, we play the fire hip animation. So they're kind of like paths. So if we're aiming, let's take this path. If we are not, let's take this path. And that's what we're going to be working on. So what I want to start with is a simple integer. So we're going to do int, let's do user input, and set this equal to 0. Now let's go ahead and just get a simple input value. So we're going to allow the user to enter in a value. So we're just going to do enter in your favorite number. And then we're going to do std sin. We're going to do user input. And that's just how you can get the user's input and store it inside of an integer. So I'm going to go ahead and print this out real quick to make sure everything's working, which honestly it should. So control F5, enter in your favorite number, 5, and it prints out 5, so we know we're good. So we are printing out to the console with cout. Think of this like console out, and getting the user's input with sin, or think of it like console in. So input, output. So we have the user's input. Let's do a comparison with a simple if statement. So if user input is greater than, let's say, 5,000, what we're going to do is print out, we're going to do cout, that is a large number. And I'm using the \n, by the way, to indicate a new line, which I didn't want to do here. So if we enter in, let's do 5,001, or I did 50,001, my bad. Let me do 5,001. It says that is a large number because that is what we're checking. So if user input is greater than 5,000, which we entered in 5,001, print this message out. However, if I do enter in 5,000, nothing happens. And that is because we want it to be checking if it is greater than this value, not greater than or equal to. So greater than just checks. So if we have greater than 1, that means the minimum value for it to be true would be 2. If we did greater than or equal to 1, the minimum value for it to be true would be 1. So that brings us to our other types. So here we have our greater than, which you should know from basic school, just normal math. We have our less than. We have our greater than equal to. So it would just be the greater than sign and then the equal sign right after. So if we enter in 5,000 now, it prints out that is a large number because it is checking if it is greater than or equal to 5,000. We have our less than equal to, and then we have our equals. So for our equals, it's just two equal sign. So if I do 5001, you can guess what's going to happen? Nothing. It skips it. If I enter 5,000, it prints it out correctly because this is now true. So this is how you can compare different types. Well, not different types, but different, different methods, I guess, of comparison. So greater than, equal to, less than, yada, yada, yada. So now we also have does not equal. Whoops. Does not equal. So this will make it so if user input does not equal 5,000, print this. So you did not enter 5,000. So I'm going to just do 1, 2, 3. You did not enter 5,000. But if I enter 5,000, it skips over that because this is false. Because user input is equal to 5,000 when we are checking to see if user input does not equal 5,000. And that check is using the exclamation point equals. And this also pertains to booleans as well with the exclamation point, which I will show you shortly. So let's do a check. So if user input is greater than 5,000, let's print out that is a big number. Else, as you can tell I'm wrapping in curly braces, we want it to print out that is a small number. So std cout, that is a small number. So now when I run it, got a semicolon. If I enter in 400, it prints out that is a small number. But if I enter in 6,000, it prints out that is a big number. And that is ultimately kind of your normal if-else. If your if statement is true, run whatever's in the if statement. If it's false, run whatever is inside of the else statement. And that's kind of how you want to keep a flow, because you don't want to just have an if statement, for example, and then have whatever would normally be in your else outside of it, because you'll end up with this result. If I do 6,000, it prints out that is a big number and that is a small number. Well, 6,000 can't be both a big and small number, well, depending on who you ask, but it prints out both in this case because we don't have any sort of control here, which we get with our else statement. So that's how you would kind of use an if-else. Now, there is also else-if. What I'm going to do is I'm just going to do an else-if between our if statement and our else statement. And here I want to do a big comparison. I'm going to do if or else if user input is greater than 100,000. I want to print out that is a very big number. So now if I do something like 500,000, that is a big number. However, even though we have this else if here, where it states if user input is greater than 100,000, it's not printing, even though this is technically true. The reason for that is, once this is checked, so if our user input is greater than 5,000, and we entered in 500,000, this would also be true. And once this is true, it ignores everything else. It just skips down to here and continues the flow. Now that is where we can have multiple checks inside of our if statement. And there's two different types of these. We have, well, technically there's a couple more, but we're going to use and or. So what we're going to be checking first is with an and. So we're going to do a check. So if user input and, by using the double ampersand, user input is less than, let's do 100,000, but we're going to do an less than or equal to, because this is checking 101,000 and bigger. This is checking less than or equal to, or sorry, less than 100,000. So now if we enter in 500,000, it prints out that is a very big number, which is this else if statement here. And if I just print out 5, that is a small number. You can have several different types of comparisons. Well, you can have several different comparisons inside of your if statement. And that can go on for however many you want to put in there. Now there's also the other type, which is or. So I'm going to go ahead and remove these else ifs, and we're just going to do an or check. So we're going to change this up. So if user input equals 5,000 or user input equals 100,000, print out that is a big number. So if I print out, or if I enter in 5, nothing happens. If I enter in 5,000, it prints it out. If I enter in 50,000, nothing. If I enter in 100,000, it prints it out. So it doesn't have to be both conditions. So it can be if this one is true, or if this one is true, then the if statement is true. However, if I change this to an and, which wouldn't make sense at all, because it can't be both values, this is always going to be false, because user input cannot be 5,000 and 100,000 at the same time. We would have to have a different value. So if I do int value 2 equals 100,000, and we'll do a check. So if user input equals 5,000 and value 2 equals 100,000, print it out. So I'm going to enter in 5,000, and it prints it out. But if I enter in 5, nothing happens, because this is false, but this is true, and we need both of them to be true, because we're asking if user input is 5,000 and value 2 is 100,000, then the if statement is true. If one of them is false, or if both of them is false, then the if statement is false. So if you ever learn truth tables, this is kind of where it comes into play. That's how I did the logic here inside of this fire function. So if we have ammo in the magazine, so if current magazine ammo is greater than 0 and B can fire, we continue and we go ahead and fire our firearm. And that's how that works. However, when you're comparing a lot of values like these, specifically integers, and you're looking to get specific values to check something, you could do this, if user input equals 5,000, else if user input equals 5,001, else if user input equals 5,002, and so on and so on and so on, for whatever values you want. You could replace it with a switch statement. Now, a switch is for specific values, instead of an if statement, which is just kind of miscellaneous conditions. So a switch statement, for example, we do switch, then we have the value we want to test. In our case, it's user input. We can test it against several different things. So I'm going to do a quick case check here for values 1, 5, and 10. So I'm going to do a case 1, and I'm going to print out something. is 1. Then I'm going to do a case 2 is 2. Or sorry, I meant to do 5. Case 10 and is 10. So if user input is equal to 1, it should print out is 1. If it's equal to 5, it'll print out is 5. If it's 10, it'll print out is 10. However, there's a slight problem with this, and I will show you. If I print out 1, it prints out all three all three conditions. As you can see right here, it'll probably tell me, unannotated fall through between switch labels, and I'll show you why here in a second. If I do 5, it'll print out 5 and 10, and if I do 10, it'll just be 10. The reason for that is, with switch statements, when one of these conditions are true, we need a way to break out of it, because it's going to test user input against everything unless we choose to break out of it. And as you can assume by the word break, it's called break. This will break us out of this if we enter in 1 and we don't want to have 5 be printed out or 10 be printed out. So I'm going to do a break on case 5 as well, and 10 even though it's not technically needed. So now when I enter in 1, it doesn't print out all 3, it just prints out is 1, which is correct. That's what we want. So that's kind of how you can use switch statements. Now there's also a default, and let's print out is default. If we enter in some other number, let's say I do 500, it'll run to the default case, and it'll print out default. So essentially, if it is none of our cases, we have a default case that will run to kind of allow us to run other code. So think of default as an else for the switch statement. And that's how you can kind of control the flow of logic. So normally you might want to call a function or something in here, or do something small, change a value. It doesn't really matter. I don't know how you would want to use this, because unfortunately I don't think I have an example of it. Actually I do. Let's see, it would be in the zombie, I think. Let me just find it real quick. Here we go. So in the hit, so this is where the zombie gets shot. I did a switch based on the location that it was hit. So I have case 2, 3, 4, and 5, which those are different values given by the hit part is, we have this function get hit part. So this returns if it's a limb, this returns if it's a chest, stomach, neck, head, and so on. So that's what it's checking. So if, case 2, meaning we hit the chest, we set the hit location to equal an enum of the value chest. If we hit, 4, which is a head, actually 4 is a neck, we just set the hit location to equal head because we're ignoring the neck. We're just adding that as a headshot. And if it equals 5, which is a headshot, we set it equal to head. So that's kind of another way we can use a switch statement inside of Unreal Engine. So you're going to be using if-else primarily, and switch statements on top of that here and there. However, in some cases, your compiler will probably convert your if, several if statements or whatever you're doing, depending on what you're doing, to a switch, depending on, like I said, what you're doing. Because compilers kind of adjust your code as it compiles, so to speak, to really make it more efficient. So like, if I was trying to write something specific in assembly, and then I write that same thing in C++, when I go to compile, that C++ code is probably going to be a more efficient version of whatever assembly code I wrote. It'll have its own improvements because they have gotten to the point where they're just very, very good at what they do. So it's not too big of a concern. but you do have options, and switch is something you will probably end up using when you have several different cases that you want to compare against. Hence why I think they call it cases, because, well, in this case, do this. In that case, do this. In this case, yada yada yada, so on and so on. So I think that's why they're there. So that covers the basics of the if, else, and switch statements, and hopefully that kind of made some sense. I'm not really going into syntax or anything like that, but you can kind of follow along. I'll probably actually add a quick little video for syntax. I don't know, since I didn't cover it. I don't know if I really want to anyways. It's not really needed. There's so many videos for it, and it's pretty simple to pick up on. But yeah, that hopefully covers the basics of it to where it, it's explainable. So now that that's out of the way, we can move on to for loops, while loops, and for each loops in the next video, which is something we also use quite a lot. So I will see you in the next video.